Hi everyone. All right, so we're looking at 2.2.1 today. How can I build it? Here we're talking about adding integers, whether it be positive or negative integers. And so we're going to start with a really fun lesson. Um, Units of length can be placed one after another in line to find a measure of an object's length. Today you will look at how to compose or put together different lengths to create a new total length. All right, so now you guys are going to do an activity called crossing the tightrope. And let me tell you, this is a fun activity, okay? It says Cecil is an acrobat in a local circus. His job is to move across a tightrope from point A to point B while blindfolded. Could you imagine walking across a tightrope blindfolded, suspended in air? He can only move using the distances that you tell him to move in your instructions. He needs to reach the end of the tightrope, point B, to take his bow and go down a ladder. Assume the platforms on both sides of the tightrope extend infinitely and have no end. Cecil may go past the ladder. However, if he does, make sure he turns around and goes back toward the ladder. So this last part here is really important. All right, you can make Cecil walk past point B here, but if he walks past, then you have to bring him back. All right, so you have to figure out, how am I going to bring Cecil back? We're only going to be using addition problems. So think about how you might bring someone backwards using addition. All right, so now it says your task. Work with your team to find different combinations of the lengths given in parts A through E below that will allow Cecil to move from point A and end at point B, the end of the tightrope. You may use each length as many times as you would like. For each crossing, look for at least 3 different ways to get the acrobat across. All right, so we're looking for at least 3 different ways. For each solution, draw a diagram on your paper that shows how the available lengths were combined to get Cecil across the tightrope. All right, so now we're going to be using this really cool digital tool called Acrobat Numberline, and it's in your CPM ebook. So all you do is you click on this blue hyperlink, and it brings you to the game. It's right here, okay? And it's a little bit of a learning process how to use these tools at first, but what you can always do is click up here on this question mark. You guys see what I just did there? Click up here on this question mark, and then it tells you all about this game. So it's like, welcome to the game. And then as you click next, it tells you how you can move Cecil across the rope, tells you how you can zoom in and zoom out, tells you how you can add lengths that you want him to move. And then you guys see this play button right here? You're going to click play once you add your lengths. All right, and then we'll be able to see if Cecil will successfully get to the end of the tightrope. And then this is really important here. Um, Over here, if you click on this little piece of pen and paper, then it's going to give you the option to create a puzzle, choose a puzzle. You're going to want to click on choose a puzzle, and then you'll be able to take him to different tightrope lengths. All right, here's a little bit more on that. Okay, so everything you need is right here, this question mark, if you forget. But first, we're going to try to get Cecil across a 24-foot rope. And so I'm thinking, okay, let's make him go 8 feet, and then another 8 feet, and then another 8 feet, right? 3 8 feet, that's going to give me 24. So now I'm going to click play. And hey, look at that. He made it to the end. So it says, congratulations, your equation worked. And so the fun part here is we have negative numbers, all right? So let's say I send Cecil across 10 feet. Oh, I need to get rid of these pieces first. All right, so there I got rid of the pieces by just clicking on them. And now let's say I send him 10 feet, 10 feet, 10 feet, and he's past this 24 mark he wants to be at. How can I get him back? And I can't use subtraction here. I can only add movements. All right, so now I'm going to go into my negatives because I'm at 30, right? 10 plus 10 plus 10. And I'm going to go back 4 and then back 2. You guys can see it if I zoom out like this. All right. All right, so now let's see if this gets him to 24. Press play. Goes past it, and he comes right back. So even though I only added movements, my equation here worked. 10 plus 10 plus 10 plus -4 plus -2. All right, so now we're adding negatives. What I would like you to do as you go through and use this tool is write down each of your equations that work, all right, and draw diagrams for them. And so, for example, in this case here, maybe I'm going to try to go to a new puzzle and click on the 17 feet one, and I go forward 10 feet, forward 10 feet, and I'm going to bring them back 3 feet, see if it works. All right, so that worked out, and so what I'm going to do is draw on my paper exactly what I just did. So if you look at the top, I went 10 feet, I went another 10 feet, and then I had to go back 3 feet to get to 17 feet. All right, so I used my diagram, my green and red, to show how he got to 17 feet, the end of the tightrope. All right, so that's what you're going to do using this tool. All right, and you'll notice it says the length strips are given below, and so you're going to try to, for example, go the span of 24 feet using these given lengths. And that's the first one that we saw when we went in. So you just go to choose a puzzle, and then you choose whatever length you're dealing with. So in this case, 24, and then my next one I'm dealing with a length of 17 feet. And so I'd go back into my tool, and I would go up to the pen and paper, and I would choose a new puzzle of 17 feet. All right, you guys see how that works? And then remember, you're going to draw a diagram representing each of your successful attempts. All right, and then it says for 232, represent the way that the acrobat could move across a span of 17 feet. Mara wrote the expressions shown below. So all of these expressions here show 17 feet. All right, whether you are adding two positive numbers and then adding a negative to finish it off, like I did in my example, right? 10, 10, and then to go back 3, or if you're just simply adding. All right, and so you're going to defend each conclusion with a diagram. So just like that diagram I showed you a second ago, that's going to be what you're going to use to defend these equations here. Like, this is how I know 10 plus 10 plus -3 will get you to 17. And think about, what does that -3 in part D represent, okay? What does this piece right here represent? And then it says, write numerical expressions for each of your solutions to part C of problem 231. So I know it sounds confusing, but if we go up to 231, part C, like it says right here, that's going to be 231, and part C would be this one right here, 15 feet with these given lengths. Okay, so that's what we're referring to. Write numerical expressions to represent getting to 15 feet. All right, and so here's an example of that. Here I have it labeled on my paper, 233. All right, there's my diagram. I went 6 feet, 6 feet, 6 feet, then I'm at 18 feet, and then I had to go back 3 feet to get to 15. All right, and then you'll notice here's my numerical expression. So 6 plus 6 plus 6 plus -3, right? We can only add movements, we can't subtract. So I have to add a negative number. So that's what you're going to do for 233. And then 234 says, when combining lengths to make a new length, like you did to get the acrobat across the rope, does the order of the numbers matter? All right, so does it matter if I go forward 5 and then go back 2 and then go forward another 5 and then go back 2 again? Like, does it matter if I do my adding negatives in the middle or the beginning of the equation? Or can I just add them at the end like we've been doing up top here? All right, so like in this example, doesn't matter if it's 10 plus -3 plus 10 instead of 10 plus 10 plus -3. All right, so does the order matter in which the numbers are placed in the equation? That's what you're trying to figure out. And then finally, 235, designing the tightrope. In problem 231, we found multiple ways to combine lengths to get an acrobat to the end of the tightrope. And this time you are given the lengths of 2, 5, and 9 feet. And so now with your teammates, you're going to decide if the acrobat could cross a tightrope with these given lengths: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 feet. All right. And then for each length that you think is possible, you're going to write an expression to represent the acrobat's movements. So remember, that expression is going to be a numerical expression. All right. So it's going to be adding. We're only using addition here, but you can add negative numbers like we see here. Okay. And then part B, you're going to complete, and they'll do it for your core problems, and then you'll move on to the math notes. The math notes are unrelated to the core problems, but you're still going to need to look at these for your homework. And so this talks about using generic rectangles to complete your tough multiplication. And so, for example, here, if our multiplication problem is 67 times 46, which definitely seems difficult at first, if you didn't want to use the standard way of solving, you could break it up into this rectangle over here. And here we see 60 and 40. And so you would multiply 60 and 40 together to get 2,400 or 2,400. And then you could do 60 times 6 to get to 360, 7 times 40 to get to 280, and 7 times 6 to get to 42. It's like a Punnett square if you remember doing those in science class. And then with all of these numbers we have, we could add them together, and that would give us our answer, our total sum, okay? And this is basically what I just explained, but you could break 67 into 60 plus 7 and 46 into 40 plus 6. So then you do 60 times 40 to give you 2,400. And then you can do 7 times 40 to get you 280. And then you can top it off with 6 times 60 to get 360. And 7 times 6 to get to 42. And then you just add all those numbers together, and that gives you 3,082. So just another way of solving when you have a tough multiplication problem like 67 times 46. And then when you move on to your review and preview, you're actually going to start off by using that method to solve 54 times 32. And we have our homework help here, so I can use my math notes, but if I'm still unsure, it says draw a rectangle. So I draw a rectangle, and then I need to break it into the different parts, right? 32 into 30 and 2, 54 into 50 and 4, and then I need to multiply, in this case, 50 times 30, 50 times 2, 4 times 2, and 4 times 30, write in my 4 results that I get, and then add them all together. And then if we go back, the next problem set is 237, and again, we're going to be using that tightrope game to complete these. All right, the E-tool is right there for you to click on. And with the given lengths, you're going to try to go the span of the given tightrope. And then 238 says simplify each of the following expressions to find the length of the tightrope. So here, when it says simplify, it's basically saying solve. All right. So in this case, it's saying if I go 7 feet and then another 3 feet, so now I'm at 10, and then another 2 feet, so now I'm at 12, and then I add a negative 4 feet. So think if I'm at 12, and I have to go back 4, now I'm at 8. All right, so that would be my simplified version of this problem. That'd be my solution. Then it says 239, copy these incomplete number lines and label the missing numbers on each of them. All right, so remember here we're looking at how many times we need to jump to get from 0 to our first number. And so here I'm going 1 jump, 2 jumps. You guys see that? So I'm going from this hash mark to this hash mark, that's 1. And I'm going up another hash mark, that's 2. So 2 jumps. And then I need to take 20 and 0 and find the difference between those two numbers. Well, 20 minus 0 is going to give me 20. And so I'm going to do 20 divided by the number of jumps I had to make, in this case 2, So 20 divided by 2 would give me 10, which means I'm going up by 10 each jump. And then I can use that to write in the missing numbers. Same thing over here. I'm looking at how many jumps I'm making. 1, 2, 3, 4 to get to 32.4. Well, the difference between 32.4 and 0 is 32.4. And so now I'm going to do 32.4 divided by my number of jumps, 4, which should give me 8.1. And so I would show my work there, and that'd be my answer. And then for 240, here we're looking at a 4-quadrant graph. All right, I remember that quadrant means 4 because of quad. All right, think about like a quadricep has 4 different muscle parts, or like a quad wheeler would be like a 4-wheeler. All right, or quarter, you think QUA. It takes 4 quarters to make a dollar. That was my thought there. So here we're looking at a 4-quadrant graph, and the coordinates x and y values for point A, so we're looking at point A right here, are -3 and 5. Okay, so what does that mean? Well, x and y values, which are shown here, x first, y second, that shows you where you're going to be on the x-axis and where you're going to be on the y-axis. All right, so first I'm looking at the x-axis. Do you guys see this right here? That x? That's telling me I'm looking at this line. All right, so if my first number is -3 and that's the x, I'm going to look at my x-axis and I'm going to look for -3. Well, -3 is right here. And so I know I'm going to be right here to start. And then the second part of this is my y number. All right, so 5 is my y. And so I'm going to go on my y-axis. Do you guys see this y up here? That's my y-axis. And now I'm going to look for +5. Well, here's +5. And so I'm going to go from -3 up to +5. And there we are. There's point A. All right, so do you guys understand how that works? First number, you're looking at the x-axis. Second number is going to tell you your point on the y-axis. And one way that I remember it's x and then y is if you're curious why I'm single, you would have to ask my ex why. All right, so there's a little bit of math humor to hopefully help you remember. And so now you're going to name the coordinates for points B and C. Here your coordinates are given. Now you have to figure out the coordinates for B and C. So again, here's B, and I'm going to take a look at where it is on the x. So 1, 2, 5, right? 5 over. And then I have to look at how many down. So I'm going to go 1, 2, 3, 4, 5 down. And here we are at point B. So I'd write -5 for my x, comma, -5 for my y. All right? Then you complete C. And then it says for 241, Gracie loves to talk on the phone. All right, for this problem, it'd probably be more Snapchat, texting, Instagram for you guys. But this is how many minutes she's on her phone over the course of 9 days. And so using this data, you're going to find the what do you mean and the median. All right, and then complete question B. And then you're going to turn in all of this. All right, I want you to turn in the core problems, or the explore problems they're called. And then I also want you to turn in the review and preview, okay? So not just the review and preview today, you're going to be turning in both. And I'll have them both posted, submissions for each of those in Canvas, all right? If you have any questions, please let me know, but this is all that you'll need to know for 2.2.1. How can I build it? Enjoy the e-tool, be creative with it, all right? So try to go forward a whole bunch and then have to bring yourself back by adding negatives. It's kind of fun, all right? And that does it. Thank you.